hadn't done it. The people are joining now, so we'll give it a couple of minutes.
Hello, everyone. My name is Maria, and I'm part of the Resilient Engineering Association webinar team, along with my colleagues Anthony, Sadip, and Guy. We'd like to thank you for joining us today in this third webinar of the 2025-2026 series, in which Dr. Craig Foster will talk about, sorry, I thought I had the microphone off for a second. He will talk about adaptive capacity. Before starting, just a few housekeeping notes. The presentation will last about 30-35 minutes, and it will be followed by a Q&A session led by Sadip. Please feel free to post your question at any time using the Q&A box. And if you would prefer to speak live, just use the raise hand function after the presentation. The session is being recorded and it will be made available in the LinkedIn website and in the Resilient Engineering Association website as well. And with that, I'm very pleased to hand it over Beth Lay, the president of the Resilient Engineering Association. Beth, over to you.
Thank you, and good morning and good afternoon and good evening, everyone. Thank you for joining our first webinar of the season. We will be holding webinars monthly. So I want to thank the webinar team, Maria, Surdeep, Guilherme, Anthony. Thank you all for your work on putting this together, and looking forward to the next webinars. So I wanted to just share a little bit about the resilience engineering situation. So I'm going to say something that when I say it's going to sound so obvious, but in a world where surprise is not rare, it's normal, we need resilience engineering more than ever, because resilience engineering is not about returning to a normal state. It's about being better prepared for those surprises, which seem to be everywhere these days, and as well, working well in uncertainty. So REA's mission is to connect people, just as we're doing today, to bring together all of us so that we can create collective resilience throughout our community. So our topic today is especially timely in the U.S. As most of you know, we had a crash recently at LaGuardia Airport between an Air Canada flight and a fire truck, in which 2 pilots were killed. And so there's been a lot of talk in the U.S. about the air traffic control system being beyond the limits of capacity, and how the air traffic control workers or the air traffic controllers are actually performing heroics as part of normal work. So we're especially excited to have Craig with us today, and I'll hand over to you, Anthony, to better introduce Craig. Thank you again for being with us today.
Good afternoon, everyone. It said when you do a PhD, it said that when you actually finally take the defense survivor, you are the go-to person to contact, to consult and inquire about that particular subject. So it's a great pleasure to have Craig here with us today. Craig completed his PhD at Southampton University last year, exactly a year ago. He defended against Patrick Waterston from Loughborough, and I know for a fact that one of the questions that came up was safety 3. So there's an interesting question, adaptive capacity and safety 3. So Craig was a mathematician. We worked together in NATS on a number of things. Where one of the things we will discuss today involves a particularly interesting case that for us at the time that we're exploring safety 2, we could test that and explore some of those ideas that came in 2013 really, and we were playing with these in February 2014. So it's a great privilege to welcome Craig here. We'll have a couple of Q&A questions immediately after the session, just for an open mic, but we will then go through the question and answers in the question answer component in Soho. So please do not shy away from putting questions and answers into that or questions to that component. We'll get there. Craig, over to you.
Thank you, everyone. Some very kind words. Can I just check that everyone can see the slide? I assume that's okay, and everyone can hear and I guess see me as well. Thank you for those kind words. Last time I was introduced at one of these sort of events was in my previous role, where I was my job title was Future Safety Specialist, and the introducer said, "Here is Craig Foster. He's a future safety specialist, and that's one day he'll be a safety specialist," which was kind of sort of ironic at the time, as I was concerned with how safety would develop, and that's sort of where this thesis and my interest has sort of continued. So this is, as has been said, this will be 35 minutes of your lives. It was really sort of 7 years of mine. And as the presentation title says, it's Adaptation as a Source of Safety in Complex Socio-Technical Systems. So hopefully you find it interesting, and I'm looking forward to questions at the end. So first of all, when we talk about adaptation, we inevitably want to talk about rules. And I think one of the things that sort of has struck me through this work is we need rules. So rules keep us safe. They provide a historical precedent. They set standards of behavior. They encode the strategies which we found to work. They also bring order to what can be sort of disorder. They set the expectations, and they allow us to assure the work if we need to sort of convince others that this work is going to be safe. And when things happen, we can then inquire into why the rules didn't necessarily work in that situation. However, one of the things that we see, and everyone on this webinar will be familiar with, is as soon as we start looking at work, we find things like violations, normal violations, informal strategies, and workarounds. And what's really going on here is people are just making the work work. They're fixing the impairments to the flow of work so that they can meet the goals that have been set, or just achieve them in a slightly more efficient way. In general, a lot of workarounds we see are implemented in response to just the complexity of work itself. However, and one of the things that sort of has interested me is this idea that the language of deviations and workarounds and shortcuts is quite negative. And the image here is one that I found online during some of the research, and it might be a bit too small, but the language of the actual news article is, hospital clinicians' workarounds pose risk to patient safety. And this is clinicians who were using electronic healthcare records, printing them out and annotating and writing on them. Now, the point here is this is seen as a negative. This is workarounds that are endangering lives, but it's actually clinicians making the work and working around the limitations of that system. So there's a negative language around sort of deviations, violations, and adaptations, but there's also a positive language around actually when we improvise and innovate and be creative, we can create safety through sort of hero complex or sort of heroic actions. And this sort of tension is something I'll sort of talk about through this webinar. One thing also is it's worth saying is the need, we have the institutionalization of adaptation and the need to ingrain it in our rules as well. So management in our organizations will talk about rules and procedures, and we'll talk about how we should follow the rules to stay safe. And this is an example of that. So this is CAA publication 493. This is the Manual of Air Traffic Services, part 1. So this is very much the rules of air traffic control, which is the organization that I work in. Section 1, chapter 1, I guess it's subsection 1, paragraph 1.1. The first meaningful part of this rule book says air traffic services within the UK are provided in accordance with the Air Navigation Order, which is law, rules of the air regulations, and standardized European rules of the air. Generally, these are in line with standards and recommended practices. So what are we saying here? There's basically follow the rules. and that these rules are appealed. We should follow these rules, and possibly there'll be sanctions for you if you don't follow these rules. However, literally the next paragraph says the Manual of Air Traffic Services contains instructions and guidance for controllers providing air traffic services to cater for both routine and many, it doesn't say what, emergency situations. And this is the sort of the key point. Nothing in this manual prevents controllers from using their own discretion and initiative in response to unusual circumstances, which it doesn't define, which may, so again, putting that back on the individual to decide whether, which may not be covered by the procedures. And similar language exists in other countries and in other industries as well, particularly maritime has very similar things. And what this is doing is creating this grey area in the middle, which is where adaptation lives. But why have we written it? Because air traffic in the UK and elsewhere is incredibly complex. It's the context of complexity that means that we have to write our rules in such a way that it has this grey area in the middle. And attendees here will be familiar, this creates a double bind even. So, I mean, Sid Decker talks about this. This is that retrospectively we can sort of judge these violations that people may break when they break the rules and say that they're foolish, especially if they fail. But then we might also say that they're adaptive if they succeed. And this is this sort of double bind that's created, where if workers have violated the rule and things go wrong, then they'll be reprimanded as risk takers. But if they didn't violate and things go wrong, so they blindly followed the rules, then they're reprimanded for being non-adaptive. And it's this which is like sort of stuck with me over the years, that this idea of, well, we're placing this into the sort of position of the person who's having to make these decisions, and what is it about them, this thing, and the organization and the teams that they work in that enables these capacities and capabilities that we clearly require because we write them into the rules. So one of the things is, obviously when you start the thesis, you do a literature review, and I cast my net very wide. I looked across industries and domains for definitions of adaptation, and there are a lot. And what we find is it captures a multitude of ideas. This idea of the ability to self-organize, the ability to make sense of conflicting demands, to reevaluate what you're doing when the context changes, and possibly innovate to cope with surprise. That there's a sort of almost tacit acceptance that we need to break the rules sometimes, that boundaries may need to be stretched to achieve a safe outcome, and that there's this continuous real-time compensation going on through trade-offs and informal practices and strategies that are going on that somehow create, makes the work work. And I guess one of the things, and I'll come on to this in the case study that Smokes has alluded to, is this idea that it is ubiquitous, it is everywhere, and it's normal, and that while we recognize it and obviously write it into our rule books and possibly tacitly acknowledge it in work, it's generally hidden in plain sight. And part of what I wanted to do was understand how we can sort of bring it to the fore. So one of the things that sort of I sort of found across the literature was this: there's really sort of 9 core ideas to adaptation. And through the research, I eventually grouped them into these 2 ideas. So I guess the first there, adaptive memory on the right, is this idea that captures experience, rules, and strategies alongside a second set of ideas that relate to the capability to innovate, the ability to improvise, to make trade-offs and judge when the rules are going to be insufficient. I'm not going to go through all 9 of these. I'll refer you to the thesis if you want, or you can look at some of the papers, but each of these has its own definition that explains some of the ideas that the literature talks about when we talk about adaptation. So on to the case study. So this is really, as Smokes has alluded to, where all of this started. So back in 2013, we were doing a workshop, and that workshop was sort of excited by the possibility of a number of events that had happened in UK airspace at about that time, that posed a challenge to what we were doing, and I'll sort of talk through that here. But first off, I need to give you a little bit of sort of context. So for those sort of unfamiliar with air traffic or aviation in general, so hopefully this will make sense. So when aircraft are climbing, they have a pressure setting, and this is what's known as the QNH, and that's set at the airfield, and it causes the altimeter on the aircraft to show the altitude of the center point of the runway. So it's basically to help aircraft to land. But as the aircraft climbs, we need to move on to a standardized pressure setting that's globally standard, because otherwise you'll have too much local variation. So we move from one pressure setting to another, and we do that as you pass a transition altitude, and that's in the UK mostly it's at 6,000 feet. So the standard thing that happens is, say for example here, the local pressure is the same as standard pressure, which is at 1013 hectopascals. An aircraft will be told, big jet 123, climb flight level 80. So it'll be at, say, 5,000 feet, and then we're moving to flight levels, which is on standard pressure. So what happens is the aircraft climbs through the transition altitude and then swaps. In this case, it doesn't, because they're the same. And what happens is 8,000 feet becomes flight level 80, and the aircraft climbs levels off, no problem. You've then got the time margin is sort of a function of how, the climb performance of the aircraft and that distance. So you've got the pilots have a certain amount of time to make that change on the aircraft. However, on a low pressure day, so typical low pressure in the UK would be about 980 hectopascals. This happens. So same thing, big jet 123, climb flight level 80, the aircraft will climb through the transition altitude at 6,000 feet, change from 980 to 1013, but that suddenly becomes a lot less. So flight level 80 is nearer 7,000 feet than the old, what would be 8,000 feet. So the aircraft climbs to this new flight level. As you can see, there's considerably less time to do that and get it right. Well, what happens when it goes wrong? So I think it's quite clear what's going to happen. The aircraft climbs again, climb flight level 80. It's a low pressure day. They go through the transition altitude. However, for whatever reason, it's a busy cockpit. It's a busy time. They forget to change and leave the aircraft on the local pressure. So instead of that 8,000 feet going sort of down, and where flight level 80 is there, they continue climbing and climb up to what would have been 8,000 feet. And that's called a level bust. So they have bust their level. And that's not very good. So 19% of all level busts are due to this problem called altimeter setting error, ASE. And it rises to 32% if you consider just looking at business aviation. So that's an unauthorized deviation from the ATC assigned level, which is not great, and it's especially not great if something's coming the other way. So these are real risks, and one of the chapters in the thesis and one of the papers that resulted talks through a real incident in some detail to look at the circumstances of how this happens and the consequences. So we can't allow that. There's a risk. So something must be done. And there are a lot of things that are done in UK ATC, tools, supports, training, notices to pilots, new systems, automation have all been tried, but this risk still exists. And back in 2014, we'd had a number of incidents that suggested that something needed to be done. And the idea was add a phrase. So instead of just saying big jet 123 climb flight level 80, controllers were instructed, so told that they had to do it, to add the phrase standard pressure setting at the end. The idea being that by adding these 3 words and 6 syllables, it would be a reminder to pilots to change to 1013 hectopascals. It would only be on days of low pressure, but controllers would have to do it, and it was felt that this would work. So it was the idea being here. So the aircraft, as it climbs through the transition altitude, they would change and do exactly what they expect to do. And it was risk assessed and introduced. And within a couple of days, we had various incidents reported by controllers through our sort of open reporting system. They pointed out that standard pressure setting is not an English phrase that non-English speakers would expect to hear. So they queried it. The frequency is very busy. That's really annoying. Also annoying is if you are a proficient English speaker, so a British Airways pilot, say, hearing flight level 80 standard pressure setting is redundant. Flight level 80 means standard pressure setting, so you don't need to say it. Because it was interpreted by our regulator as a pressure change, it has to be read back. But because people didn't realize that, they didn't read it back. So there was just all this confusion, and through all of this, it's just sort of created a lot of sort of like ill feeling, or it was basically just like, this was a bad change that controllers didn't really like. And it was sort of exemplified by the last sort of incident that we looked at, where a pilot misheard standard pressure setting as route direct Detling, Detling being a point in the London terminal manoeuvring area that's nowhere near sort of Heathrow, and they disappeared off across the airspace. Again, because it wasn't expected phraseology. So what did we do? We didn't obviously leave this trial running. It was cancelled. So on the left, you have the original temporary operating instruction that introduced the pressure setting, and we reverted it back to a safety notice that had been issued to controllers prior to the change to say, do what you were doing before, because it contains this phrase, again, back to some of these ideas of institutionalizing adaptation, that nothing suggested in the safety notice is intended to prevent or deter an individual controller from applying whatever techniques or phraseology they choose to mitigate the risk in a particular scenario. What had been uncovered was that controllers had already adapted. They understood the risk. They live at the front line, they work at the front line, and they had already identified a number of ways. They knew which aircraft, like business aviation, are more likely to bust their nut. They slowed it down. They used this phraseology with certain aircraft types. They watched. They had many, many strategies for managing this, and the temporary operating instruction had constrained their adaptive capabilities. So that sort of got me sort of going with the thesis in a way, because it's saying, well, how do you prevent that from happening again? How do we uncover these techniques, these pre-existing adaptations that already were in the work prior to us changing? So how do we find work has done? How do we make changes that don't constrain the positive things that are already going on in work? How do we ensure that after we make a change, we still have those capabilities to adapt? If we do things like the temporary operating instruction, where we're codifying adaptation into the rules, we took a strategy that some controllers used and wrote it into our rule book and said, you have to do it. How do we do that without affecting the flexibility that we know is required? And can we enhance this capability without creating chaos? We can't necessarily say, do whatever you want. There needs to be some structure, but how do we avoid this sort of chaos? Now, one of the things that the results, the outcomes from the thesis work was a set of probes and keywords built around the adaptation factors to encourage a broader discussion early in the change process to try and uncover adaptation and adaptive capabilities. So within a sort of semi-structured interview, you would work with experts to tease out these unwritten workarounds, the hidden features that keep us safe. So, for example, just asking questions like, would this affect your ability to cope with the unforeseen? Can you still make decisions in surprise? If things went wrong, how would you solve this? Does this affect your problem-solving capabilities? Does it invite intentional risk-taking? Are you just going to break this rule anyway? Does it impair what you normally do? Does this change affect the balance of the goals in air traffic? Is there still going to be sufficient slack as a result of this? What about novices and the more experienced? Are they going to do things in different ways? Does it affect your previous understanding of the procedure? Would you be able to learn this and share your learning with others as a result of this change? Are there things in this that aren't being addressed? Have we written a rule that doesn't consider the edge cases? Are these practices that you find that you operate with in work, are they going to be affected by this? Does it change that flexibility? And basically, does it continue to sort of break the link between cause and effect? Are you still going to be able to predict what's going to happen and understand how work works? And that seemed to work. So during the thesis, I ran trials with some of our controllers, gave them the temporary operating instruction as it was, and basically talked them through adaptation and used some of these questions. And they were able to appreciate the challenges the temporary operating instruction had, and I made sure that they were controllers who were recent, so they hadn't heard the story, although it is sort of well known. So the last bit of this sort of the webinar, and the last bit of the thesis and my continuing interest is really this idea of, so that's sort of like, you can create a method, you can write this into sort of how you do risk assessments, but what is it about organizations, teams, and individuals, and how do you manage adaptation within an organization? Now, one of the things here is, and there's a lot of work, and I know David Wood's done some really interesting stuff recently around this, on the paradox that seems to exist, that there's this paradox between the rational view of the need for prescription, and we balance that, or we contrast that against the need for this in the moment decision making. That when we look to alternative perspectives on adaptation, such as in biology or management science or complexity science, that there's a lot of parallels and analogies that I think the safety community can draw on. And part of that is around this view that organizations and successful systems exist on this point of the edge of chaos between order and disorder, that successful organizations seem to be able to balance the demands of creativity, innovation, discovery, autonomy, and the need for efficiency, control, and the reduction of variance. And complexity science describes complex adaptive systems as operating at this boundary between order and randomness. And the question I sort of posed is that the desirable state? And if it is, how do you achieve it in organizations that are highly regulated, and we love rules, and safety critical, where the consequences of failure can be quite catastrophic and unacceptable? So how do you do this? And sort of, you come across this idea of an adaptive tension, that there's always been a tension between, new ideas may be better, but the old ideas have kept us safe. That when we create new things, we have innovation, but if we have too much of it, it becomes unconstrained, unconstrained random strategies. Organizations, there's little coherence. It's very hard then for people to assure things, especially where we have introduced accountabilities. But also, if we have too little innovation, and I think this is where a lot of the focus has been, if there's too little creativity, we can get stuck in like arbitrary strategies or rules, local minima, with little resilient capability if our context changes. And this is the sort of the tension and the balance. And if you'll indulge me, there's the biological parallels are really interesting, where you can draw a parallel between the organization and the organism. And there's an interesting example which I found and I'll share, which is the idea of the industrial melanism of the British peppered moth. So moths, as the Industrial Revolution of the 1800s created more coal soot, obviously the skies, the ground all darkened because of this coal dust. Now, the British peppered moth was sort of cream and white, which obviously, standing up against a black ground, you're going to get eaten by the predators, because very obvious. But the area's moths darkened just as the skies and ground darkened. So this is a visible response to the contextual change. So you can start to see some of the sort of organizational parallels. The idea being that there was enough variability in the moth's gene pool, so this the gene pool and the genetics, the thing, the essence of the organism, such that innovative strategies, this idea of darkening, is found to work. They don't get eaten. And then because of that, it's getting passed on as a rule through their genetic encoding, that there's this synergistic relationship between innovation and memory in response to a changing context. And these are all moths. And what we see is that successful systems, successful populations require these things to be in balance, this innovation and structure, the competing demands of being able to test sufficiently many, sufficiently novel strategies, but retain the coherence in memory of the things that actually work. And that these are then in balance, and it's that's driving this sort of adaptation, this adaptive capability within organizations from organisms. And I find sort of the parallels are really quite intriguing. So this is sort of where I sort of got to towards the end of the thesis, is this idea that to manage the safety of complex endeavors, where you can draw the sort of parallels between a successful organism and a successful organization in the sense of the safety of its services, that in complex endeavors like those, we note that these systems aren't really just complex. They're not just designed for efficiency, control of variance. That actually through the rules that we've written, we've stumbled across a way of structuring our systems for adaptability. And so they've become complex adaptive systems. And that by bringing together people, procedures, and equipment, we've delivered the emergent property of safety that wasn't present in the components themselves. That safety has emerged through this process of engineering the systems into complex adaptive systems, rather than just having them be complex. And that was the whole point. The point was we wanted our systems to emerge into being complex adaptive. And there's a challenge where we're rationally designing our organizations to be complex rather than complex adaptive. And it's this idea of trying to find the balance between innovation and memory and live at the edge of chaos. So towards the end, obviously I was getting quite tired after nearly 7 years of thinking about this. I restructured the 9 factors and added a further 7, because you can never have too many, into a number of ideas that I think relate to how organizations can get to a point where adaptation is emerging in their complex endeavors. And that's the sort of outer ring of this idea of this model. And just relating those back to the factors, you get things like, well, okay, we want innovation in our organization. What do we mean by that? We want the ability to come up with new ideas. We want a vibrancy in the organization, a culture of bringing new ideas out, of listening to people and taking on board their ideas, that we'll embrace breaks from experience, like rule breaking. We'll look at why we're doing that we'll experience we're quite happy to take the leap forward, and that we can provide environments where it's safe to test new ideas if we can't do it live in the operation. But also that, and I think there is this role again of rules and memory, that people have a memory, that they have knowledge of the signals, the cues, when to change, that we instill the ability to learn and to impart knowledge on others. So in NATS, we use a lot of collegiate things where we bring together groups to learn together so that they can learn from individuals' experience as a team. When we write rules, we should write not just what works, because that's what the rules encoding, but also why it works, to instill this organizational memory of there's a reason why we do things in this way. But also to create ways of enabling novel strategies in work, to take what really does work, that innovation, that new ideas that improve efficiency or improve safety and address risk, and encode those in our rules as well. So in conclusion, and that's sort of where I got to, adaptation is and remains an emerging idea in the development of safety management. I think it's sort of forgotten maybe that rules really are important, but creativity is important as well. And that the core challenge for safety management, especially in highly regulated industries, is in managing this tension between adaptive memory and adaptive innovation, and how we live on the edge of chaos. That's all for now. That's my sort of time up. I will flag that there are a number of publications that came out of the thesis, which you're welcome to sort of to read, and obviously the thesis itself. And I believe my contact details will be made available, so I'm more than happy to talk to anyone about the contents of the presentation. Thank you very much.
Thank you very much indeed, Craig. Well done for interesting presentation. There are no questions in the Q&A component, so we'll just fire a couple of questions off to you to begin with. The edge of chaos is a fascinating notion. We know where it exists within complexity science, but can a system be mix or have a hybrid state of edge of chaos? Can it work at one particular group of elements and not at others? Can they coexist?
It's an interesting discussion point. I think one of the things you sort of see, and I mean, through the work that I was doing, I didn't necessarily subscribe to any particular school. I didn't want to go down sort of too much down a sort of resilience engineering or even HRO. And I know that there's been some really interesting work comparing the two and recognizing they're not actually that different. I think whether they can coexist is I mean, I've sort of said it's like, well, the characterization I've seen has been like, it's like a balance point. This idea of, in certain circumstances, you'll need more rules, but then then it needs to revert back. And in different contexts, that balance point will be at different places. So I think in terms of like, can they coexist? I think, yeah, possibly. I think it's just this idea of where's the balance point.
And part of that was triggered by the notion of adaptive tension, which I found really, really interesting, because how do you navigate that adaptive tension? Becomes from an organizational perspective, in terms of resilient performance, really interesting. It's like the economic notion of opportunity cost. There is a point where you'll get benefits, there's a point you're not, and therefore can we therefore sort of constrain that in that way?
Yeah,
I was
going to say that's a really interesting point as well. I mean, the idea that, I mean, one of the things I was trying to do is find a way of, like, find a framework where you can create this. So a former colleague of ours is sort of fond of saying, use the company's processes against it. And this idea of, we are never going to get away from the safety management system, as an idea. So what is it about the safety management system that I can use to sort of, infect it with this idea that we instill creativity? A safety management system is sort of designed around structures and quality, the quality of safety work and things like that. And it's like, yes, but, and it's like, we do other things. We do other things to keep it safe that aren't necessarily written in the rules, but we can use the framework to create those. So for example, you could write a rule that says after any incident, we'll have a sort of collegiate review. Well, that's sort of getting to that point of, you're trying to share learning across organizational boundaries, getting teams to talk to each other, but you've used like a process to try and enable it. Again, using, use a process or rule to create something that, like, not breaks the rule, but is like trying to affect it and build these capabilities.
Thank you. We could continue discussing this, and we should. Sudeep, over to you. We've got some questions in the Q&A.
Yes, we have a few. So the first one is from Bethley. Can you give an example of how you are surfacing adaptations that you want more of?
Okay, so I think what was interesting was in part of the testing of some of the methods, I sort of went looking for, well, when do we do adaptation now? And one of the things that we found was there's a piece of UK airspace around London where it's sort of lots of crosses. So there's lots of complexity where aircraft are sort of going one way and they come across other aircraft. And from that, the controller managing that piece of airspace, it's really complex. And what we found, and there was a project that was running that was looking to assure some of the strategies that had been identified. The controllers had found a way where what they did was they climbed the aircraft so that it avoided this cross. But in climbing it, they're actually stealing a bit of airspace from the sector above. So sectors aren't just like 2D, they're 3D. So they were stealing the airspace. But to do that, they had to coordinate with the other controllers. So they had to make a phone call. Now, they had found a way of doing this, and this way the phone call, because that's an interesting sort of, it's like a speed bump in the work. So can we encode this adaptation that the controllers had found? So what would happen is the aircraft would go into the other airspace coordinated. They'd phone the other controller, and the controller would go, no, because it's too complex. I don't want to do it. So they'd have to then solve it by other means. Or they could say, yes, and the aircraft would climb and be handled by the other controller. Or they could do a hybrid, which was, yeah, okay, you can have that level, but you're working the traffic. You keep talking to them. I'm not doing that work. You do the work. And one of the things was like, it was like a big phone call to agree this. And this project was just like sweeping all of these adaptations up and safety assuring them and saying, well, actually what we'll do is we'll make it so that they have to take it. And it's those sort of adaptations that in this example, it was like, okay, cool, we're going to do that change, but what's it affecting? What are the other strategies that this controller who looks at all of these things, what else are they doing that is going to be affected by that adaptation change? So that was sort of, that's an example of one. I mean, there was another one where they looked into doing it and then realized they were doing the same as the temporary operating instruction, where they were encoding something that was then breaking other things. So hopefully that answers that question.
The next one is from Will Gallego. I hope I pronounced your name correct, Will. Coming from a place where regulation is in flux, specifically tech or software engineering, do you see the gray area wider in similar places? And if there is a wider band, does that lend itself to anything like greater risk of getting wrong, wider range to find adaptation, etc.?
Okay. I think, yeah, so I think in other industries where possibly the risks are different, that's a really it's an insightful question. Let me think. I think one of the things, I guess, is related to like accountabilities and how you manage that gap, that gray area. It's like I think the point is related to almost like how wide is the edge of chaos boundary. I think it's that if it's that, it feels like that's something related to the risk appetite of the organization. Like as a senior manager, not that I am, as a senior manager in NATS, am I quite happy for controllers to find informal strategies, or am I going to, and have more creativity because I know that will make it safer? But has this now gone so far that actually I need to encode some of these in rules and safety assure them to make sure that they're appropriate? That it's like there's this sort of like, we allow a buffer because we know we can't write a rule for everything. So we have highly competent, highly trained individuals who are competency assessed because they can make those decisions. around where those grey areas exist. I guess I think probably it relates to the risk appetite of the organisation, and ultimately then the individuals in that organisation, of how wide that band, that tolerance is, I guess.
Right. Yeah. And it's always challenging to define the boundary conditions. Like, what is the edge of that performance envelope? And that's always a fuzzy area. All right. The next one is from Jane Wright. Have you considered the possible conflict of rules between organizations or between sectors? How can we consider the impact of adaptation on others?
So that's a really good question. So one of the things I was really keen on looking at was what we see is these capabilities exist across the organizational hierarchy. So for all that point at the end is like, how do you structure an organization for adaptive capability? And then you can sort of take that through the different layers and go, but how do teams work? And how do individuals work? And then you go, how do teams of teams work? So how does like one group that's maybe found an adaptive capability work with another group that maybe is following the rule a bit tighter? And I think it's a really interesting challenge, and especially when you get to like the boundaries between organizations. I think I left that as an exercise for the reader at the end of the thesis. I think one of the things is in air traffic, we have an awful lot of rules that are globally standardized. For obvious reasons, aircraft can fly anywhere in the world. You want pilots who can understand what's going on in that area. The conflict, back to the case study, the conflict there is like the transition altitude, that 6,000 feet, isn't globally standardized. So we have rules that say what you should do, but then we introduce local differences. Yeah, it's hard. I guess the best example is possibly that one again. I mean, it was this idea that a controller had found a way, and then that way had spread. So one controller had found a way, and we organize our controllers into watches, and then someone from another watch will spin onto another watch to cover like sickness or maternity leave or something like that, and they'll look and go, "Ooh, that's an interesting way of doing that. I hadn't thought of that. I'll now take that back to my watch." But the impact there is it's on that other controller of, well, now I have to take that aircraft that you're going to climb into my airspace. And I think that's when I was talking about this idea of having the conversation, possibly it's a case of having the conversation with the right people, making sure you've got the right people in the room. So when you go, hey, this is a great thing, if you've just got a room full of controllers who do that airspace, they're going to go, yeah, it's great, we'll just send it up and off we go. We've solved that problem. But if you're not thinking across the boundaries and go, well, hang on a minute, what's that controller going to do with that extra aircraft? That's a bit of a problem. So I guess when you're scoping your change and asking about adaptations, it's a case of looking beyond the system boundaries about who's going to be affected.
It also reminds me of the tension between the general and the specific. You can always take these adaptations and find what it represents at an abstract level, but then there's always a tailoring to the context. And then that bit of tailoring is that I think requires some level of agency. You can't be too specific in terms of how you prescribe it to each situation. Mm-hmm. So Richard Bai says, great presentation, thanks. How do you support frontline teams to make the risky decision to adapt outside of the rules when, with hindsight, the gap between heroic innovation and recklessness could be a matter of luck?
That's getting into ideas around, I guess, having a positive safety culture, having a positive sort of a just culture. Air traffic, and I think aviation is rightly quite proud of its safety culture, and the fact that, say back to that examples, a controller had made, was doing that, and it's within the rules, it's within the assured envelope of the rules, but for the sake of argument, say that they were slightly outside the rules, and they then said, you know what, I did this, maybe I shouldn't have done that. We don't judge that. We don't necessarily sanction that individual for bringing this to our attention, because that's ultimately self-defeating, because they won't tell us again. So building that trust of, I'm adapting in this way, we found a way of doing this that seems to work, bringing that to the attention of procedure designers, or the people who write the rules, and for them not to sort of then sanction it or judge it, judging it on the basis of, well, these are experts, they are highly competent, highly trained, very experienced safety professionals who are operating within a goals and a structure that we create. How, why is it, take a systems view, why is it that they're doing this? Why is it that they found something that is locally rational to them? And understanding that sort of just culture, safety culture implications of what we're doing. Yeah, I mean, yes, luck plays a role. I think it's that you want to get yourself into a position, I guess, where you're lucky. But I think you do that through your point there, to make the risky decision to adapt. I think it's that, well, how have you created an organization where that's classed as risky, where they feel that is like they're really going out of their way and pushing the envelope to solve something? I think it's that, how have you got yourself into that situation where that's classed as risky? And then, obviously making sort of the post hoc sort of judgments of it. I think it's that we try to create the environment where that's seen as like a culture of improvement, rather than like waiting for it to sort of, oh, they did that, that's really risky. How do you challenge that in a constructive way to say, well, every other watch is doing it like this, no, you're doing it like that? I think it's like trying to avoid that point, I guess. Hopefully that's answered my question.
Any other questions from anybody? Looks like for now that's all there is one more just came in. Okay. Will Gallego. Using the framework that as system complexity increases, the agent's own model. Using the framework that as system complexity increases, the agent's own model decreases rapidly. Does that affect the viewpoint of the gray area?
Yeah, that's an interesting point. I think one of the things that comes out of the literature around that, I guess the analogy there is to like between sort of the novice and the sort of experienced person. Or, I mean, NATS has done some interesting work looking at biometrics, where we looked at eye tracking, and it was a controller comparing a controller who had just come back from holiday. They'd had 3 weeks off, and we put them in the simulator to do some sort of validation and competency checks. And we compared that against someone who was like fresh out of the operation, that morning. And what you found was the person who was less practiced was like reverting to like older archetypes of work. They were heads down, they were looking at the strip board. They weren't necessarily looking up and sort of doing scans. Whereas the person who was fresh out the operation was down, up, through the tools, up, around, doing this perfect scan. You could see this in the eye tracking data. And I think that's the sort of, it's that, why were they doing that? It's feeling like they felt uncomfortable. The complexity of what was being presented was, they weren't in that that place. So does that affect the viewpoint of the gray? I think, yeah, this is where it gets into a sort of quite an individual perspective of risk. And I think it's building that around, building the answer there around the view of where that individual's gray area is. And I guess that's from an individual, team, organizational point of view, that idea of there will be different gray areas depending on the sensitivity of that person to that level of complexity. Hopefully that answers the question.
Yeah. This was a really thought-provoking discussion, and of course, an excellent presentation, Craig. Thank you so much. I will hand it back to either Maria or Anthony.
To me.
Okay.
Thank you very much, Sadip, and thank you so much, Craig, for such an interesting, really interesting presentation and discussion afterwards. And well, we finish here for today. We've got more webinars coming in the next month. Will be the next one. The date will be confirmed in the website, the Resilient Engineering website, and in the LinkedIn site as well. And thank you all. We hope to see you here in the coming webinars. And thanks again, Craig. Thank you.
You're welcome.